Hello everyone. Today we are going to see class 8 science chapter number 3 force and pressure part 3. In the previous parts already we have discussed about the different kind of forces like contact and non-contact forces, balanced and unbalanced forces, and in the second part we have discussed about inertia, different types of inertia, unit of pressure, formula for the pressure, and pressure in the three different states of the matter, that is solid, liquid, and gases. Today we are just moving ahead in this. Today we are going to talk about the atmospheric pressure. As we know that Earth is surrounded by the different kind of gases like nitrogen, oxygen, hydrogen, carbon dioxide, different gases are there around the Earth. When we talk about the atmosphere of the Earth, it starts from 16-kilometer height. From the 16-kilometer height, and it extends up to the 400 kilometer in a very dilute form. Actually, if we want to see it with the picture, you can see over here this particular part which is near to the earth's surface. This is the earth's surface we have, and the part of our atmosphere which is near to the surface of earth is very dense. If you will compare this to these two sides, you will find that the air particle are much closer in the lower section as compared to the higher section. This shows that as we move away from the earth's surface or above to the earth's surface, if we are moving, then the density of the air is reducing, and once it is reducing, it reduces the atmospheric pressure, because as already we have stated about the pressure's formula is nothing but the force applied on a per unit area. When we see about this particular unit, 1 atmosphere is equal to the 101 into 10 raised to 3 Pascal, which also we call as a 1 bar, or that is equal to 10 raised to 3 millibar. Atmospheric pressure, when we talk, is also known as the hectopascal, HPA, the short code we are writing for the hectopascal. And when we talk about the atmospheric pressure, they have given over here the atmospheric pressure on our heads, however the cavities in our body are also filled with air. Means we don't experience that atmospheric pressure on the earth's surface generally, because the body which we are having inside that, it's filled with the different kind of the fluids and the air present in the arteries and vein, which is also filled with the blood simultaneously. And due to that, the pressure what we have inside and the pressure what we have outside is getting balanced, and due to that on the earth's surface we don't feel that atmospheric pressure. But when we go to the higher altitude, our body starts to experience that atmospheric pressure. And that's why you might have heard about when the mountaineers, they go on the rock climbing, or when they go on the mountains, then sometimes mountaineers, they are getting the nose bleeding through the nose. Why this is happening? Because the blood pressure what we are having inside becomes more as compared to the outside atmospheric pressure, because it's a higher altitude, mountains are at a higher altitudes, and due to that what happened, the veins which is present inside the nose, the small capillaries what we have inside, they are bursting due to the excess pressure inside the veins as compared to the outside or the external atmospheric pressure, and that's why they are getting the bleeding in the nose. Now, here with the picture also they have shown, you can see the earth at the center and the atmospheric pressure from all the side. And here also they have shown the atmospheric pressure. You can see as the height is increasing, the atmospheric pressure is reducing over here. At the sea level, the atmospheric pressure is 101 into 10 raised to 3 Pascal, is acting on the tabletop of size 1 meter square. Means if we have a area on the sea surface which is 1 meter by 1 meter, then on this particular area, whatever pressure will be there, atmospheric pressure, that will be almost equal to 101 into 10 raised to 3 Pascal. Now here, the next what they have given is about the buoyant force. For this activity they have taken, in this picture they have shown the activity. Suppose if you have a one plastic bottle, put the cap of that or the lid of that, tight it and leave it in the tank filled with the water. Then you will find that it will start floating like this one. Why this one is floating? Because there is air filled inside the bottle and that air is lighter than the water, and that's why it's not sinking inside. On the other side, the one plastic ball, the hollow plastic ball, if that also we are living on the water surface, it will also start to float. At the same time, if the same bottle, we are opening the lid of that, we are filling it with the water and putting the cap back and then leaving it, then we will find that the bottle is not going towards down or the bottom of the tank, but it float inside the water. Why this is happening is because of the buoyant force. Because at the time when there is a force of gravity or the gravitational force which is exerted by the ground on the bottle which is filled with the water, same time water gives a reaction to that force and that takes it upward, which we call as a buoyant force. That buoyant force balances, if it balances the gravity or the gravitational force, then it will start to float inside the water. And if the gravity is more, then it will sink at the bottom, and if the buoyant force is much higher than the gravity, then it will go upward. Now here, if you want, then they have given a definition as well. Then from here you can see the upward force acting on the object in water or other fluid or gas is called buoyant force. This definition you can write for the buoyant force. Now this buoyant force, what will be the value for the object? In that, two factors are there. The one is the volume of the object, that is one factor. The buoyant force is more if the volume of the dipping object is more. Means if the volume of the object is higher, then the buoyant force will be more. Means if we have a 1 square centimeter box and instead of that if we have a 2 centimeter squared box, then this will feel more buoyant force and this will feel less buoyant force. Why? Because the volume for this is a more. Other side is what they are saying is a density of liquid in which they are immersing. More the density of liquid, more is the force of buoyancy. Means if the density of a liquid is more, if when we talk about the water, if we add a salt in it, what will happen? The density will increase for the liquid or the water, and due to that more buoyancy will be there. That's why you might have heard about the Dead Sea. Dead Sea, what exactly the concept is behind it? In that Dead Sea, there is a huge amount of a salt or the minerals, and due to that, the density of water is a much higher. And that's why the small insects can crawl on the surface of the Dead Sea. Further, next when we talk about the another concept is there, that is the Archimedes Principle. Simple example I am taking. If we are having an iron nail and we are dropping in the water, it sinks down. Whereas when we talk about the ships made up of a steel or the iron, they can float on the surface of the water. You can see the small iron nail cannot float on the surface of water, but the large ships made up of a same iron can float on the surface of water. Isn't it different thing? And this different thing, or the amazing part of a science, is explained by the Archimedes, which we call as the Archimedes principle. First, we will see what the statement we have for the Archimedes, what he has given this principle. In this principle, he states when an object is partially or fully immersed in a fluid, a force of buoyancy acts on it in the upward direction. This force is equal to the weight of the liquid displaced by the object. Archimedes' principle, he just explained the concept of a buoyancy or the buoyant force. What exactly will be the value of that is explained by the Archimedes. He said that whenever object is partially or fully immersed in a fluid, a force of a buoyancy acts on it in the upward direction. Like this, it will be acting upward direction. This force is equal to the weight of the fluid displaced by the object. Simple example if I am taking, if you have a glass filled with the water up to the rim, if it is filled with the water, and you're dropping one solid object like eraser, if we are dropping inside it, what will happen? Water will spill out, and that water which is spilling out will have a certain weight, and the amount of that water which is coming out, the volume of that will be equal to the volume of the eraser. Means whichever object is getting immersed inside, suppose instead of that one small magic ball if I am dropping inside, then it will displace the different amount of water from the glass. Means every object, when it is partially or fully immersed in a fluid, it feels that buoyancy upward, and at the same time it force the force what they are experiencing, that will be weight of the fluid displaced by the object. Whatever fluid they will displace, the weight of that is nothing but the force what they will experience. This was the principle given by the Archimedes, and this particular principle is used in a different kind of instruments like lactometer, hygrometer, and designing the ships and submarines. They are designed with the help of this particular principle, which we call as a Archimedes principle. Here they have given information about the scientist Archimedes, who had given this particular concept. He also found the value of a pi, which we are using in a maths. The pi, that is 3.14, is the value, or 22 by 7 is the value. While calculating the area of a circle, we are using it. You might have used this. So this is about the Archimedes principle. The next part is density of the substance. That formula already we know, that is density is equal to mass upon volume, and the unit is a kg per meter cube. Another term what we are having, that is the relative density. Relative density is nothing but comparing a density of a substance with respect to the density of water. That is called as a relative density, and there is no unit for the relative density. You can see the formula, density of a substance upon density of a water. This brings the ratio of two equal physical quantities. It has no unit. Relative density is also known as the specific gravity. So this is about chapter. Thank you.